Morning, let's continue with our LeetCode top interview questions. Container with most water. Start the timer. Okay, an integer array height of length in vertical lines. Okay. Find two lines that form a container such that it contains most water. Maximum amount of water. Eight, 6, 2, 5, 4, 8, 3, 7. Okay, so we want to find so the amount of water would be the index of this minus this, and then times the lower of the two. Okay, so the farther apart, that will give us higher chance of having more water in this. So we would wanna go from the left end and right end and towards the middle. Let me see. So what if we start here and here? Okay, so when we are at 1 and 7, the maximum amount of water that it can hold is only at the height of 1, and then we have 8. So that will be 0, index 0, and index 8. So that will be 1 times 8. So that's the amount of water we can have when we are there. Now we want to move the pointers. Now which one do we move? We naturally want to move the one that's shorter, because then we will have higher. Okay, yes, we always want to move the pointer that's shorter, because otherwise we will never have more water, because the shorter one will only ever give us as the same height. It will only go lower, it will never go higher. If we keep this as one of the edges, no matter what we do on the right hand side, it can only go as high as this. It can even be lower, but not higher. Right, okay, so that's why we want to move the pointer with lower value. Okay, so now we move this towards the middle. Now we have 8 and 7. We calculate that. Let's store that in a variable just to have this maximum running. So we have that, and now what do we do? How do we move the pointers? Same logic, we will move the shorter one. So this one with a lower value, we will move that to this, and then we'll move it to this. We will calculate this again. If it is higher volume than the last, then we will replace. And then if it's okay, now interesting, we have the case of left and right are pointing at the same value. In this case, we can move either of them. Why? Okay, let's see. So let's say we move the left one to this and this. So now we have this and this will move, this will move, this will move, this will move. What if we move the right one? Then it will be moved here, 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 here. Okay, so in this case, all these ones in between them are lower, so it will not give us more water anyways. What if we had one that's higher? Let's say this one is actually higher. Let's say it's at 9. These are at 8. This is at 9. So what would that mean? If we had moved the left one, it would be going here, here, here. And if we had moved the right one, it would be here, here, and the left one going inward. Okay, so in that case, since all the lower ones will not give us more water, right, it will, when we are going towards the middle, when we see a lower value, that will not give us more water than what we have already encountered. That's an important point. So it will only have more water when we see a higher value. So that's the only chance of getting more water, because when we're going towards the middle, the x-axis is already shrinking. The difference here is already shrinking. If the height is also going downward, then there's no chance we will get more water. So only chance it will get more water is if the height is growing. So if we had higher in between, okay. So I think I have the algorithm, but I'm still not totally convinced that when we have the same height, it's exactly the same no matter which one you do. What if we had one that's higher? What if we had two that's higher? Let's say this is 9 and that is 10. Like my examples are telling me that no matter which one I move, I would end up with the same result, but I would really like to have some kind of logical or mathematical proof for that. Okay, let's okay, let's have that for later. Let's write the algorithm first. So we have left pointer starting from the left, right pointer starting from the length of this height list, -1. So, well, left is smaller than right. Let's see. We also want to have this amount that will be running. Amount is it's right minus left times the minimum of left and right value Maybe this is not super clear. Yeah, let's move that out. Let's call this volume. It's actually current amount. Maybe that's better. Current amount is this times the lower one of those two. Okay. So if left is the shorter one, then we increment left, else we increment, decrement right, return amount. Okay, that's very efficient. So I have apparently done this back in January. Yeah, I do have memories of this question. Okay, so back to the case when it's the same, because right now if it's the same we're just decrementing the right pointer. So when one is the same, I guess we could think in this way. When left and right have the same height, since we are only interested in the case for the maximum amount of water, so no matter which one we're moving, we will always end up trying out the maximum amount. Because because the only interesting cases are when the height is higher within these two same height. And since these two are the same and there is a higher height in the middle, so those two pointers will be moved towards the higher one. Okay, so if there are two that are higher, let's consider, if there are two, so say this one is higher and this one is higher, then no matter where we start, we will both move towards, we will end up at these two higher ones because we are always moving the shorter pointers, so they will end up at these higher pointers. And then we don't really care what's in between because that's the same thing. So that's the case when both will move towards the higher height. What if we only had one that's higher? That's the only this one. Then they will also move towards it, but in that case the maximum volume it can get is, it will be this one difference here times the height here. That's the only chance it will get higher. And if we had moved this, then that would be moved again. Interesting. Okay, I'm thinking about if this one is 9. Let's say this one is 9. So if we had moved the left pointer, in this case, that would go here. And we're comparing these two still, so that's shorter, we're moving that, that's shorter than we're moving that. So we end up with this 9, 8, difference is only 2. But if we had moved right pointer, it will end up here, it will move here, and then we would be calculating this difference of 3 times height 8. So in the case when we're moving left pointer, we actually never even calculate that. Calculate this case. So now I'm not quite sure. I'm not very convinced. We will have to see if other people have given some explanations. Alright. Let's do time and space. So time, we are traversing from left and right end towards the middle. We are doing some simple calculations. That's all constant here. It's all constant. And we are looping this once. So that will be linear time. Space-wise, all constant. So linear time, constant space. That's really good. No follow-up questions. Okay, let's see if we can find some explanations for the case when left and right has the same value. Simple and clear proof and explanation. Okay. Okay. Okay, same exact algorithm. Okay. Exactly, we are looking for this. You need to prove that in this case, it doesn't matter whether you do left or right because wait, let's see. If we have the same left and right, neither of them can be potential solutions because the error potential is necessarily smaller. I'm not sure about that. Oh, I see. Oh, that's very smart. Okay. Very smart indeed. So what it means is, okay, so when we have this and this, let's say we had this at 9. So since if they are shorter, then we don't even need to consider because that's gonna be a lower in volume. If they are higher though, so even if this is higher, when we're moving this one pointer or moving that one pointer, it will not be a higher volume than this one because we're always considering the shorter. So when we're, let's say this one is higher, if we are moving this towards this, sorry, I need some water. So if we're moving the left pointer towards the higher one, it is still gonna be lower in volume because now we reduce the length here and we're still using the lower height. And even if this one was taller, it will still be the same thing because the length in between here will get shorter and the height we will use will still be one of those when we're just moving one of them. So no matter which one we move, we will still use the other one as height. Even in the best case scenario, when we have a longer one, if it's even shorter, then it's just no problem at all. No chance of getting bigger volume. So in that case, it doesn't matter which one we move because none of them is gonna give us a higher volume. Okay. Interesting. Well, it doesn't, yeah, so that's very interesting logic. It doesn't mean though that there won't be any chance of higher volume in between because we could have this one that's like 100 and this one also goes to 100. Then we have 300 just in between. So inside this part, it's still uncertain what's gonna happen, but what's certain is that just by moving either one of these, one towards the middle, whichever one we do will not give us higher volume. So that's the point. Okay. Very smart. Thumbs up. Okay. All right. So I think that's all we need for this problem. Okay. Well, that's the same solution. Alright, that's it for this problem. I will see you in the next one. Let me know if you have any questions. Bye guys.